Stages of AI project cycle. Understanding the different stages of AI project cycle will help you learn the importance of each and every step in designing an AI project. There are mainly 5 stages of developing an AI project. 1. Problem scoping. 2. Data acquisition. 3. Data exploration. 4. Modeling. 5. Evaluation. Problem identification. Problem scoping. Data acquisition. Data exploring. Modeling. Evaluation. Stage 1. Problem scoping. This is the first and the crucial stage of AI project development, which focuses on identifying and understanding problem using 4 W's: who, what, where, and why. It is the analytics approach that involves taking steps to solve the problems and setting up goals that we want our project to achieve. Scoping a problem is not that easy, as we need to have a deeper understanding around it so that we have a clear vision as to what we want our project to achieve while we are working to solve it. Hence, we use the 4 W's problem canvas to help us out. Sustainable development goals. We are surrounded by problems. We are so used to these problems around us that they seem to be part of our lives. When we cannot observe a problem around us, then we should refer to the 17 goals that have been announced by the United Nations as the Sustainable Development Goals. These goals are to be achieved by 2030 as pledged by member nations of the UN. Artificial intelligence supported solutions are suggested to assist the society and government to achieve these goals that would work to improve the lives of the people living in the society all across the nations. Here is the listing of 17 SDGs as laid by the United Nations. 4 W's problem canvas. The 4 W's problem canvas includes the following 4 questions: who, what, where, why. Given below are the extensive ways to use the 4 W's problem canvas. Who. The who block helps in analyzing the people getting affected directly or indirectly due to it. Under this, we find out who are the stakeholders to this problem and what we know about them. Stakeholders are the people who face this problem and would be benefited with the solution. Here is the who canvas. What. Under the what block, you need to look into what you have on hand. At this stage, you need to determine the nature of the problem. What is the problem? And how do you know that it is a problem? Under this block, you also gather evidence to prove that the problem you have selected actually exists. Newspaper articles, media, announcements, etc. are some examples. Here is the what canvas. Where. Now that you know who is associated with the problem and what the problem actually is, you need to focus on the context, situation, location of the problem. This block will help you look into the situation in which the problem arises, the context of it, and the locations where it is prominent. Here is the where canvas. Why. You have finally listed down all the major elements that affect the problem directly. Now it is convenient to understand who the people that would be benefited by the solution are, what is to be solved, and where will the solution be deployed. These 3 canvases now become the base of why you want to solve this problem. Thus, in the why canvas, think about the benefits which the stakeholders would get from the solution and how it will benefit them as well as the society. Here is the why campus. After filling the 4 W's problem canvas, you now need to summarize all the cards into one template. The problem state template helps us to summarize all the key points into one single template so that in future, whenever there is a need to look back at the basics of the problem, we can take a look at the problem statement template and understand the key elements of it. Stage 2. Data acquisition. This is the second stage of the AI project cycle. It is the process of collecting data required for training the AI project. Data is raw information that is used to generate meaningful outcomes. If we have to make an artificial intelligence system to predict the traffic flow for a particular geographical location based on the previous traffic data, the data needs to be fed for the previous years into the system, and the machine can be trained to use it to predict the traffic flow effectively. The previous year traffic flow data is known as training data, and the prediction it makes is the testing data. The efficiency of AI system is dependent on the authenticity and relevance of the training data. Like the previous topic discussed, if the traffic data is not for the same geolocation or not for the same period last year, the predictability of the machine would not be accurate. Hence, for the AI system to be able to work efficiently, the authenticity and relevance of the training data to the scope of the problem statement is a must. Data features. Data features refers to the type of data to be collected. In our previous example, data features would be day, date, and time of the data collected. Now the next step is to know how and from where the data can be collected. The data can be collected through surveys, customers' feedback and reviews, web scraping, data extracted from various web pages, sensors, data collected from various sensors to track the conditions of physical things can be monitored in real time, cameras, live data from surveillance cameras, web cameras, etc., observations, reading and analyzing trends, application program interface, API. Application programs generate data of their own while working, like data on their servers. Nowadays, data is becoming the new raw material for almost all businesses. This data is now considered as new gold. There are innumerable sources on the internet that can provide data, but we have to be sure that the source of data should be authentic and relevant. Only then the AI project can predict precisely and accurately. There are some authentic sources of information in the form of open-source websites hosted by the government. These portals have information collected in a format that can be easily downloaded. Some of these open-source government portals are data.gov.in, india.gov.in. Stage 3. Data exploration. This is the third stage in the AI project cycle. It refers to exploring the large data to uncover the patterns or trends needed for the AI project. It is considered to be the first step in data analysis where unstructured data is explored, researched, filtered, and visualized to decide the strategy for the type of model used in the later stage. For example, if you have to buy a laptop, you need to explore your requirements of the configuration that you want of the RAM, hard disk, processor, operating system, graphic card, touchscreen or not, etc. But from this unstructured data, you have to choose the one that suits the best to your needs. Similarly, after the data is acquired, it needs to be explored to suit the needs of the AI project. Visualization of the data plays a very important role in data analysis. This visualization process has to be carried in some user-friendly format so that you can quickly get a sense of the trends, relationships and patterns contained within the data. Define strategy for which model to use at a later stage. Communicate the same to others effectively. Different ways to visualize data. The following are some of the different ways to visualize data. Data visualization technique 1. Name of the representation: bullet graphs. Description: it is just like a bar graph with extra visual elements for more explanatory comparison. How to draw. Stretch goal, base goal. Business A, 50. Business B, 20. Business C, 55. Business D, 110. Suitable for which type of data? It is used as data comparison of primary data with respect to other data and displays it in the context of qualitative ranges of performance such as poor, satisfactory, and good. Data visualization technique 2. Name of the representation: histogram. Description: it is bar graph-like representation of data where data is on x-axis and the number, count, or percentage of occurrences in the data will be on y-axis. How to draw. Number of people. Marks obtained. Suitable for which type of data? It is most suitable for representing the frequency of continuous data on a graph in the form of immediately adjacent bars. Data visualization technique 3. Name of the representation: scatter plot. Description: it uses dots to represent the relationship between two different numeric variables represented on the x and y axis. How to draw. Scatter plot. Weight, height. Suitable for which type of data? Suitable for depicting the relationship between two numeric variables such as employment and output, inflation and retail sales, and taxes and economic growth, etc. Data visualization technique 4. Name of the representation: tree diagram. Description: it is a visual representation of a hierarchy structure in a tree-like form. It consists of a root node, nodes, branches, and leaf nodes. How to draw. Root node, branches, leaf node. Suitable for which type of data? It is to calculate the probability of an event or problem stated. It can also be used for organizational structural representation. Data visualization technique 5. Name of the representation: flowchart. Description: it is a diagrammatic representation of flow of the data in a process. It uses symbols of different types to represent different steps in a process. How to draw. Lamp doesn't work. Lamp plugged in. No, plug in. Yes. Bulb burned out. Yes, replace bulb. No, repair lamp. Suitable for which type of data? It is good for representing the flow of data in a process. Stage 4. Data modeling. An important stage in the process of AI project cycle where we decide on the technique to be followed for building a model from the prepared data. It is a mathematical approach in which an algorithm is designed as per the requirement of the system which is ready to be installed to analyze the data technically. In the previous stages of data exploration, we used the graphical representation of data to make it easy to understand the trends and patterns. But when it comes to machines, it only understands the language of ones and zeros. So they only rely on mathematical representation of data. AI models: learning-based, machine learning, deep learning, rule-based. AI modeling techniques can be broadly classified into the following two approaches. Rule-based approach. This approach is based on a set of rules and facts defined by the developer and fed to the machine to perform its task accordingly to generate the desired output. These models can operate with simple basic information and data. To explain it further, let's take an example. If you have a data set that consists of weather conditions, a basics which we can predict if the lion would be visible on a specific safari day to the tourists. The parameters can be cloud cover, temperature, wind speed, humidity. When these parameters are recorded and fed in the machine giving the favorable combinations when the lion would be visible, and rest can be considered that the lion would not be visible. Now, to test the model, the machine is given a scenario of the cloud cover, temperature, wind speed, humidity. The model will compare the same with the fed in the data set, and if there is a match, would let know if the lion would be visible or not. This is called a rule-based approach. The drawback of this approach is that the learning for the machine is static, as once trained. The machine does not take into consideration any changes made in the original training data set. If the machine is tested on a different data set from the rules and the data fed in at the training stage, the machine will fail and will not learn from the new conditions encountered. Learning-based approach. This approach refers to the model where the relationship or patterns in the data are not defined by the developer. Random data is fed into the machine and the machine develops its own pattern or trends based on the data outputs. This approach is considered to take care of the challenges of rule-based systems. For example, suppose you have a data set of 1000 images of flowers. Now you do not have any clue as to what trend is being followed in this data set as you don't know their names, color or any other feature. Thus, you would put this into a learning approach-based AI machine and the machine would come up with various patterns it has observed in the features of these 1000 images. It might cluster the data on the basis of color, size, shape, etc. It might also come up with some very unusual clustering algorithm which you might not have even thought of. The learning-based approach can further be divided into 3 sections. Supervised learning. In a supervised learning model, a labeled data set is given to the machine. A labeled data set is the information which is tagged with identifiers of data. For example, clothes in a store are marked under various categories of clothing like shirts, trousers, coats, etc. They are further labeled as per gender and size. The supervised learning is further categorized as regression. It is an example of rule-based AI model. In regression, the algorithm generates a mapping function from the given data, as shown by the solid line in the given graph. The green dots shown in the graph are the data values and the solid line here represents the mapping done for them. With the help of this mapping function, we can predict the future data. For example, if we want to predict the temperature of a day in a year, we can use past year's temperature for that day as training data and can predict it for the coming year. Regression is a mathematical approach to find a relationship between 2 or more variables. It works with continuous data. This can be used for weather forecasting, time series modeling, etc. In order to get the best fit results, the distance between the line and data points should be minimum. Classification. This is another rule-based AI model. It is a systematic grouping of observations in categories. Something like categorizing plants, animals in different taxonomies by biologists. In classification, you teach the machine to perform with labeled data. Testing data is then classified as one of the labels of the training data set. The algorithm is able to determine which set a given data point belongs to by means of a classification function represented by the dotted line. The model classifies data sets according to the rules given to it. For example, if we want to train a model to identify if an image is of an onion or a ginger, we need to train it with multiple images of both onion and ginger along with their labels. The machine will then classify images on the basis of the labels and predict the correct label for testing data. Classification works on discrete data set. Unsupervised learning. An unsupervised learning approach works on an unlabeled data set. This means that the data which is fed to the machine is random, and there is no know-how available about it to the trainer. These learning models are used to identify trend, pattern, and relationship in the data which is fed into it. In this model, the major features are identified by the machine, which helps the user in understanding the data. For example, in the data of 100 cat images, if you want to understand some pattern in the data, you would need to feed this data into the unsupervised learning model and train the machine. Once trained, the machine would identify patterns in the data. These patterns might already be known to the user, like color or size, or something unusual about the cats. Unsupervised learning can further be divided into clustering. It is a machine learning approach where the machine partitions the data set into different clusters or categories based on machine-generated algorithms. The data fed to such a model is usually unlabeled or random, and thus the developer feeds in the data directly into the machine and instructs it to build its own algorithm. The machine then forms a pattern or cluster based on training data and groups those that follow the same pattern. The best clustering is one that minimizes the error. Clustering works on discrete data set. For example, if you have random data of flowers from your garden, since you are unable to find any meaningful pattern amongst them, you would feed their data into the clustering algorithm. The algorithm would then analyze the data and divide them into clusters according to their similarities based on the trends noticed. The clusters are then given as the output. Dimensionality reduction. Humans can visualize any figure up to 3 dimensions only. But according to a lot of theories and algorithms, there are various entities which exist beyond 3 dimensions. For example, in natural language processing, the words are considered to be n-dimensional entities, which means that we cannot visualize them as they exist beyond our visualization ability. Hence, to make sense out of it, we need to reduce their dimensions, which we do by using dimensionality reduction algorithm. As we reduce the dimension of an entity, the information which it contains starts getting distorted. For example, if we have a ball in our hand, it is 3-dimensional right now. But if we click its picture, the data transforms to 2D as an image, which is a 2-dimensional entity. Now, as soon as we reduce one dimension, at least 50% of the information is lost, as now we will not know about the back of the ball, whether the ball was of the same color at the back or not, or was it just a hemisphere. If we reduce the dimensions further, more and more information will get lost. So, we use dimensionality reduction here, which reduces the dimensions and makes it sensible data. Reinforcement learning. Reinforcement learning is a type of learning-based approach where a machine learning algorithm enables an agent, machine with an intelligent code, to learn in an environment to find the best possible behavior or path it should take by performing certain actions that minimize the total cumulative reward of the agent. In this learning approach, the agent learns automatically by using hit and trial methods or through its own experience using rewards and penalties. Each action performed by an agent gives reward for correct move and it signals positive feedback. For wrong move, it generates negative feedback and gets punishment and a penalty. The agent explores the environment by interacting with it freely, so that it is able to improve the performance by getting the maximum positive rewards. The best applications of reinforcement learning are self-driving cars, robotics, and a variety of video games available these days. Stage 5. Evaluation. This is a very important stage of AI project designing and training where we properly test the system to find out the efficiency and performance of the model. After the model is designed and trained, then the reliability of the model is checked using testing data acquired at the data acquisition stage. This testing data is given as an input to the newly created AI model and the output received is checked and evaluated on the basis of accuracy, precision, recall, F1 score, business understanding, data understanding, data preparation, modeling, evaluation, deployment, data.